This is problem 16.2 from Giancoli. It says how many electrons are in minus 30.0 microcoulombs of charge. A couple of things we need to know. One is that micro is a prefix that means times 10 to the minus 6. So this is the same thing as saying Q equals minus 30 times 10 to the minus 6 coulombs. And we want to know how many of these are in there. Well, remember that if you ever see how many Y are in X, the way you write that is X divided by Y equals what? And that what is what you're looking for. So in this case we have this huge charge, and I like to draw rectangles, so sue me. And this is Q, and we want to know how many E's. So one E is maybe a little tiny chunk, and then here's another E and another E. So if we want to know how many of the E's are in X, this big yellow box, okay, so Q's our yellow thing. Q is X and E is Y. Okay, so let's put this in. Alright, we have in X we have minus 3 times 10 to the minus 5 coulombs. This is going to be the number. So you count up how many of these little orange squares would make up that big yellow rectangle, and you get your answer. So minus 30 times 10 to minus 6 is the same as minus 3 times 10 to minus 5. And then we need to divide by the charge on an electron, which equals, let's do Q sub E minus equals minus 1.6 times 10 to the minus 19 coulombs. Alright, so we have minus 1.6 times 10 to the minus 19 coulombs. The coulombs cancel. That's good because we're looking for just a dimensionless number, the number of them that there are. The minuses cancel too, so we can just cancel those out. And now 3 divided by 1.6 is almost exactly 2. I mean, it would need to be 3.2, but who cares? We're in physics, right? This is 2. Now I need to do the powers of 10. I have 10 to the minus 5 minus the thing on the bottom, which is a minus 19. So this is 10 to the plus 14. That's a lot of electrons. But the point is, for reasonable amounts of charge, this is 30 millionths of a coulomb, you need a lot. This is 200 trillion electrons.